Euclid's 40th proposition says that two triangles encompassing the same area, that means they being equal to each other with equal bases and on the same side, are between the same parallel lines. So here it is slightly different from our previous proposition where we had the same base on which these two triangles were there. Now we are saying that these bases may be at different places, but these triangles may be at different places, but they have equal base. Okay, let's see how we can prove this. So again, we will use proof by contradiction. Yes. So let's say that these two lines are not parallel. If we assume that, and if you reach a contradictory conclusion based on this, that means what? That these two lines are indeed parallel. Okay. So let's see how we can go about doing this. Now, since we have assumed that AD is not parallel to BF, let's say there is some other point here, let's say G, and if we join these 2 points AG, then this line AG is parallel to BF. So if we assume that, then what does it imply? Let's do one thing. Let's connect these 2 points G and F. Okay. So now we end up with another triangle here, GEF. So remember, AG is parallel to BF. We have assumed that, which means that triangle ABC is equal to triangle GEF because they are between the same parallel lines and have equal bases. Now, how can we say that triangle ABC is equal to GEF? Because one of our previous propositions we saw that triangles with equal bases and between parallel lines are equal to each other. Specifically speaking, proposition 38. But we are already given that triangle ABC is equal to DEF. So triangle ABC is equal to GEF. Triangle ABC is equal to DEF, which means what? A triangle DEF is equal to triangle GEF. But that leads to a contradiction because based on our assumption, we decided that AG is parallel to BF. So which means G is not at D. So these two triangles are not supposed to be equal based on our assumption. So since we have reached a contradiction, we can say that G has to be at D for these two triangles to be equal, which means AD is parallel to BF. Of course, again, to complete the proof, we have to take it G above this as well. But that is trivial. Logic follows the same steps. Okay, since we have proved that these two lines are parallel to each other, that completes the proof of proposition 40, which says that two triangles with equal bases encompassing the same area and between the same two lines, then the two lines are parallel to each other. Again, as usual, let me remind you, there is a link to a PDF book which describes all the 48 propositions of Euclid's book 1 of elements. That's it for now. Bye.